Hello there, this is Miss Nakayama. Today's lesson is 12.4 Scatter Plots and Lines of Fit. So I believe you did this again in middle school, so hopefully this is a review. But remember that a scatter plot is a graph that shows a relationship between two data sets. The two data sets are graphed as ordered pairs in a coordinate plane, and they show trends in data. So first off, making sure you can interpret a scatter plot. Look at example 1. The scatter plot shows the amounts X in grams of sugar and the numbers Y of calories in 10 smoothies. How many calories, question A says, how many calories are in the smoothie that contains 56 grams of sugar? So if I'm looking for 56 grams of sugar, then I'm going to go down here to look at my grams, and 56 should be halfway between 54 and 58. So I go up and see that this point matches that many calories. So for answer A, we have that there are 270 calories. Question B says, how many grams of sugar are there in a smoothie that contains 320 calories? So calories, I'm looking on my y-axis, 320 calories. Only one available is that one right there. And when I come down, then I'll know that it's going to have 70 grams of sugar. And last but not least, in letter C, what tends to happen to the number of calories as the number of grams of sugar increases? So one of the things to know there, when they ask, when they're looking for trends, they're always looking as the x-axis increases. So when you look at this diagram, what's happening to these points, okay, as x increases, or as the grams increase, then you can see also that the number of calories are going to increase. But really what I want you to remember is when they're asking about what tends to happen, it's always going to be what's ever on the x-axis increasing. Okay? The next thing we got to talk about, correlation. Correlation is a relationship between data sets. So if you look at these pictures, as I just talked about, as x increases, what's happening to the y value? So as I go along here on the x-axis, my y value is also going up. So as x increases, y increases, but you can see if you think about the slope of the line, this is going to be a positive correlation. Down here, as x increases, y is decreasing. And again, the slope of that line would be negative. So we consider that to be a negative correlation. And down here, these points show no pattern whatsoever. And so they have no correlation. You will see later on that you could have a strong positive or a weak positive depending on how closely those dots are together. All right, so let's look at our two examples here. In example 2, tell whether the data shows a positive, negative, or no correlation. Age and vehicle owned. So this is a person's age. And as we go, can I say specifically, well, this Y value went up, but that one doesn't seem to have gone up. So this is an example of no correlation. Over here on part B, temperature and coat sales. As my temperature gets higher, then the coat sales seem to be going down because I can draw a line that would approximately represent that data. So this is, of course, negative correlation. So the next thing that we do when we have scatter plots and we identify what kind of correlation they have, then we try to draw a line of fit and write an equation of it, okay? So that's, of course, only if it's going to have a positive or negative correlation. So our steps, you make a scatter plot of the data, okay? You decide whether the data can be modeled by a line, draw a line that appears to fit the data closely, and then, and as always, I think you've discussed it, there should be approximately as many points above and below the line, and then write an equation using 2 points on the line. The points do not have to represent actual data pairs, but they have to lie on the line. So in this example, this is our last example, the table shows weekly sales of DVD and the number of weeks since its release. Write an equation that models the DVD sales as a function of the number of weeks since its release. interpret the slope and y-intercept of the line of fit. So what you would do first, and what you will have to do, what you do first is plot the points. Okay, so when you plot the points, and then you're going to draw a line that approximates, the line that you think most closely resembles this data. Okay, and then the next thing that you're supposed to do is to write an equation of the line. So you pick 2 points on the line. This is really key, y'all. They don't have to be in the data. So you don't just go pick 2 points out of here and write the equation of the line. You're going to pick 2 points on your line. So I picked this one here, which is 10, 1, because my scale, I don't know if y'all can figure out, but this is 2, 4, 6, 8, 10. So that point is 10, 1. And then the other point is up here at 5, 10. And that one happens to be in the data, and that's fine. You do not want to pick 2 points that are close together. Okay, that's not a good representation of the line if you just pick 2. So you really try to, middle and the end, or the 2 ends. So I could have used that one, but I'm not really sure what that point is. I like that one. That one seemed to be more in the middle. So I'm going to go write this equation of the line, and that line is, the equation is y equals mx plus b. To write that equation, I need to know m, which is our slope, and b, which is our line. And we've done this lots and lots. So first off, I'm going to go find the slope. And as I said, I'm going to pick these 2 points over here. I'm going to pick 5, 10, and 10, 1. So that's the change in y. So I did 10 minus 1. And on the bottom is going to be 5 minus 10. So 10 minus 1 is 9, and 5 minus 10 is negative 5. So that's going to be negative 9/5. Now, a lot of y'all don't like to do this, but I'm going to encourage you to keep practicing, because if you do it now, it'll become a habit when you use it all the time, because it's the easiest way to do it. So to continue writing the equation of the line, I'm going to use point slope form, which is y minus y sub 1 equals m times x minus x sub 1. So when I write that, and I got to fill in my y sub 1, and you can pick any point you want. I chose 10, 1. So that means y sub 1 is 1. So y minus 1 equals m, which is negative 9/5, and x minus 10. So y minus 1 equals negative 9/5 x plus 18. And to bring it all over to y equals, so that I can answer this last question of interpreting the slope and the y-intercept, then I'm going to say that y equals negative 9/5 x plus 19. So when we interpret it, the slope tells us, okay, remember from our graph that x represents the weeks and y represents the sales in millions. So to interpret that slope of rise over run, we can say that sales are decreasing at a rate of about 9 million for every 5 weeks. Sales are decreasing by approximately 9 million every 5 weeks. And then the y-intercept of happens to be 19, because that's 9/5 x plus 19. That y-intercept actually doesn't have any meaning, because if you don't have any, you have no sales in week 0. So that's the point of it. Okay, sometimes it does make sense in the problem, but on our particular problem, it does not make sense to have $19 million worth of sales when you haven't even been open. Okay, so that is all we have for scatter plots. I hope that was a good, quick refresher for you. Thank you so much for watching, and y'all have a great day.